Okay, so yeah, it's fine. Okay, so hello everyone. My name is Huma Samin and I'm a postdoctoral research associate at Durham University. And today I'm going to talk about of the SeedCon projects that were funded by MDENet. So the first project that I'm going to talk about is iDecide, quantifying uncertainty in models using artificial intelligence for personalized and shared decision making in digital health. And in this project, I was one of the co-investigator along with Dr. Nelly Bencomo, Professor Dorothy Monacoso, and Dylan Walton. And the second project that I'll discuss is ERiMA, Envisioning Risk Models for Assessment of AI-Based Application. Although I was not directly involved, but I collaborated in developing the risk analysis framework over there. And the other team members were, of course, Dr. Nelly Bencomo, Professor Peter Sawyer, and Dr. Andrew Darby. And in both of the projects, we had an industrial collaborator, that is More Life UK, um, which is an NHS service that provides weight management programs for dealing with the obesity-related conditions in order to achieve healthy lifestyle goals for the different people. So let's get started. First of all, let me discuss about personalized and shared decision making. Okay, so NHS has presented a model for universal and personalized care in which they think that patients or people will be more in control and will have a choice towards their treatment, and they will decide their treatment in collaboration with the doctor. So what happens over here, we have a doctor and we have a patient, and together they collaborate, they talk, and together they make decisions in order to achieve the patient's target health goals in correspondence with the preferences, values of the patients, and of course, their past health records. Okay, so when I talk about personalized and shared decision making, so the next thing that I'll discuss briefly is our research background, which is actually in the area of decision making under uncertainty. And we have been working in the domain of self-adaptive systems, to be specific. And what we do is that we use models at runtime to offer decision making for self-adaptive systems. That is, the idea is to have a runtime model as an abstract representation of the system that is causally connected to the system being modeled, and it offers reflective capabilities to offer decision making. So when we have a system, so when there is a change in the system, the runtime model changes, and it is the other way around. To be specific, we have been working with partially observable markup decision process to offer decision making in self-adaptive systems. We use them as a runtime model to offer multi-objective decision making. And over here, what happens is that based on the observation and the current state of the system, you select a specific adaptation decision based on the highest utility value for that particular adaptation in order to achieve a certain state or a certain goal. And in case of partially observable markup decision processes, what happens is that it considers the system working in a partially observable environment. So for that purpose, it maintains a belief over the state of the environment of the system. So considering our research background and the case of personalized and shared decision making, the main aims of the projects are, that is, map our experience with decision making under uncertainty from the domain of self-adaptive system to the case of personalized and shared decision making for digital health. And for the digital health, the case study was provided by More Life that was related to weight management. I'll discuss it in a while. The next thing is that risk and value analysis based on the decisions made. So to perform exploratory analysis, to study the relationship of the decisions, treatments, or interventions, and the goals achieved while identifying the risk levels and the utility value of the decision made, and then to decide and develop AI risk model driven analysis framework. So moving towards our first aim, that is mapping the experience with the decision making under uncertainty towards that digital health. The case study that we got from More Life was related to weight management. Okay. So in More Life, what they do is that they provide this weight management program, which is a 12-week long program to maintain or to achieve the specific health goals of the patients that they have. And what they do is that they, based on the symptoms or past health record of the patients, that is based on what is the BMI index. If the BMI index is above 40, so that is the obesity range. Uh, Actually, the obesity range starts from 35 till 40. And then if the patients have any other obesity related conditions like type 2 diabetes, high blood pressure, or any other condition related to that. So based on what is the history of the patient and the observations that they have to decide a diet plan or a weight management plan in terms of the healthy diet and the exercise plan for the patients. And of course, once they do that 12-week program, after that, then they have to decide that whether the diet plan was effective for the patients or not, um, and whether the patients should go for the weight management or weight loss surgery, that is bariatric surgery or not. A decision is taken about that. And then, of course, the weight management post the surgery. So this is what they do over there. So what happens over here, that based on the observations, which are in the form of the symptoms, past health record of the patient, you have to take decisions in terms of adjusting the diet plans or treatments in order to achieve the target health goals. That is, of course, achieving the target weight and minimizing or maximizing benefits and minimizing risks in terms of these obesity related conditions that the patient might have, such as type 2 diabetes, hypertension, sleep apnea, or any other condition. And it will be, of course, it will vary from patient to patient, depending on what the patient wants to achieve. What is the condition that the patient is dealing with? So considering this weight management case study that we have our POMDP model. We say that based on the observation and in our decision making that we offer for the self-adaptive system, we consider states in terms of the satisfaction level of the quality properties or the quality objectives that we want to achieve. So based on the observation and the current state of the system, you select an action considering the highest utility value that you could achieve in order to achieve your target goal. So when we map this, the observations will become the symptoms. The symptoms or past health records or the current situation, current observations that we have. For example, what is the current BMI? What is the specific like glucose level in terms of diabetes? What are those conditions that the patient is going through? Then the states will be represented in terms of benefits or risks. So you want to maximize benefits, minimize risks. It's a combination of that. And based on that, of course, the decision will be represented by the treatment plan. That is what kind of weight management plan that you would offer. And it will be then done, of course, in a sequence that, okay, for example, if it is a 12-week program and after every 4 weeks, of course, in the More Life, initially they have a consultation with the patient and they check their current state. What is the current state? What are the current systems? And then they suggest them a specific diet plan. Based on that, after 4 weeks, again, based on the progress made and the effects of the treatment that were done, so again, you observe those specific symptoms that now, what is the current BMI range? What is the specific glucose level if the patient is going through the diabetes or something like that? And then what is the current state? And based on that, you adjust the diet plan and something. And it will then go on for a 12 weeks. And then after 12 weeks, of course, the decision for the weight loss surgery, if the patient has that kind of like wants to go for it or not, of course, this will be done in collaboration with the patient, or you want to stick with the weight management plan, not the surgery option. So this is how it will be done. So for now, we have created this mapping, but the next step that we were looking for were to get some specific patient profile cases from More Life so that we could check that, okay, the decision making that is offered by our POMDP, how in line is it with the decisions made by the doctor in collaboration with the patient, and how effective is this decision making for the doctors in advising patients the different treatment plans. So that would be the next step, because we couldn't do it in this 2 months project. Okay. The second thing after this mapping I'm going to talk about is the risk analysis or risk modeling. So for risk analysis, what we did was, for the risk analysis or modeling of the risks, we use the concept of surprise. So what is surprise? Surprise is a measure of unexpectedness. It means that it represents the difference between that what you thought would happen, what was your expectation, and what actually happened. So that change in your belief, that what you believe, that this is going to be the situation, but after an event, something else happened. So what is the change over there? So there are different probabilistic measures to measure the concept of surprise. Bayesian surprise, confidence corrected surprise based on them. So how they measure the surprise is that in case of Bayesian surprise, we have a certain belief over the state of the system, and something happens, the change in the belief there happens. So what is the difference? How much is the deviation? So this is what Bayesian surprise gives you. The confidence corrected surprise, it is much more interesting. It adds the perspective of a naive observer into the things. For example, we are sitting in this room. We are quite familiar with this environment. We already know quite a lot about it. So an event will happen and our belief will change. So there will be a change in our belief. But suppose there is a naive observer who just enters the room, is new to the environment, and the same event happens, there will be a shift in that naive observer's belief as well. So what is the difference between the two posteriors? So confidence corrected surprise adds that level of confidence to that situation of uncertainty that we could use to assess risk in this case. So there was this problem with these surprise measures that, okay, we want to use this surprise measure to analyze risk, to model the risk situations or situations of risks. But the problem or limitation of these surprise measures were that they were unbounded. They give you a value, but you cannot analyze that how big or small a surprising situation is. So for example, sometimes a situation will be a little less surprising. Sometimes something will happen and you will say that, what has happened? So you can't measure the level of surprise. So for that purpose, in order to bound the surprise, we use a specific function that is a sigmoid function that takes as an input any real value and bounds it between the value of 0 and 1. So it gives you that upper bound for that surprise. And once we get that bound, we can easily bin it into different levels. 0 means that no surprise, no difference. 1 means that the level of surprise is quite high. And once you have this information, you will be able to then judge that, okay, the situation, something has happened, and the situation is quite highly surprising for the system. So, okay, what is going on over there? There is a risk situation, analyze risk over there. So what is happening over there? So we use this specific concept to model our risk analysis framework based on the concept of surprise. So in this framework, so in this process, what we did was we did this preliminary calculations that is related to the situations of surprise. Okay, for this case, when we were doing this, we have applied it to the case study based on remote data mirroring system that we have been using in our research. And based on that, on the different execution or simulation runs for that, we have performed all of these calculations, initial set of experiments. So preliminary calculations related to the surprise, getting the bounded surprise values, you get those specific level of surprises for those uncertain situations. Then once you get that specific bound, you group them based on a single non-functional requirement or quality objective that we want to achieve. And then for each specific grouping of the surprise, then we calculated different measures to analyze risk. That is, what was the failure rate in terms of a non-functional requirement that, okay, suppose there was a certain satisfaction level that we wanted to achieve for a specific non-functional requirement, and what was the situation of failure, where it became from satisfied to unsatisfied, and check that specific thing against the surprise level, and check that, okay, if the surprise level is quite high, okay, what is the failure rate in that particular bin? Maybe the failure rate might not be that much high in that bin, but that would be, you could say, a surprising situation. This is the nature of surprise, that something happens, it will be surprising once. The next time, if the same thing happens, you're already used to the situation. So it might not be surprising, considered as a surprise in that case. So of course, we did these different calculations to measure the failure rate and failure percentage. And then, of course, we did it, compare it with the subgrouping of an additional NFR to give us some extra surprise classifications based on the failure rate and failure percentage. And based on this, we analyzed the risks that, okay, this is a surprising situation. A failure has happened over here. What was going wrong over there? Okay. In addition to the current non-functional requirement, okay, what is the relationship with another non-functional requirement? That, okay, maybe something has gone wrong over there. A situation was more surprising over there than for this particular quality objective or non-functional requirement. Okay, and then perform the risk analysis. And we performed these initial set of experiments on our remote data mirroring case study, where we consider a trade-off or optimization of different quality properties. We consider 3 quality properties: minimization of cost, maximization of performance, and maximization of reliability. And where the adaptation actions are in the form of these 2 topologies. That is, one topology has an effect on the satisfaction of, suppose, minimum spanning tree. It supports the satisfaction of cost, but it will have a negative impact on the satisfaction of reliability, because we measure reliability in terms of the number of active links. More the active links, more reliable the network is. And redundant topology supports more reliability than the operational cost. So we applied this risk analysis framework, and these were the initial set of experiments results that we got. We did the binning, and most of the surprising most of the failure situations that we got, percentage of failures, were in these particular bins. So the bins are numbered in this way that it represents 0.3 represents the range of 0.3 to 0.4. So we had a surprising situation in that. In case of that, 0.7, which is the level of surprise is high, but the failure percentage was low over there. And for the confidence corrected surprise, of course, for comparison purposes, we had checked that. In a similar way, we also calculated the failure rate, which was that, okay, what are the specific, in a particular bin, what are the specific situations of failures, number of failures that we get to the overall deviation values, surprise values that we have in that particular bin. Based on that, and then based on all of these things, we came up with different levels for risk that, okay, for example, if we can do other things as well, but this is just an example that, okay, if we have higher failure rate in a specific bin that we have, so we say that it could have a higher risk level. And the other way around for both the confidence corrected surprise and Bayesian surprise, we did that. Okay, so for both the projects, we had these research outputs. So we had a workshop paper that explains this risk analysis framework, which was accepted in the requirements engineering conference workshop. And we had also for the second research project that we got, we have organized this tutorial on speculative design and requirements engineering to identify more situations of risks. A tutorial session was organized for that. So the next steps for this are that explore further the case of personalized and shared decision making by exploring different patient profile cases in consultation with More Life UK. And then apply decision making offered by POMDPs for personalized and shared decision making and evaluate the decision making offered, of course. And based on all this research that we have been doing, we have also got another research funding from Durham University, which was an impact acceleration account research fund that we had. And we have won this funding for a project of around 1 year, which is now named ERiMA. The first one was iDecide for the doctor. Now it is ERiMA. Clinical tool for shared decision making for treatment of menopause system. And over here we have an NHS surgery. We are working with collaboration with them, and they are going to provide us with the specific patient profile cases for this. And of course, we are going to work on it. Thank you. Yeah.